Hello, my name is Haidar, and now I'm presenting my Handin 2. And this Handin contains the I chose the first problem, which is billboarding. So, billboarding, what does it do? What is the problem of using billboarding? Why do we have it? Billboarding, what it does is basically creating, transforming 3D complex 3D objects such as bushes, grass, trees, signs that use a lot of complex geometries, and those are very computational. They require a lot of computation power, so therefore we want to limit the amount of computation power for the computer in order to get high frame rates for our game in order to run it smoothly. So therefore we transform these objects into 2D sprites and then just map them on boxes that are always facing the camera. And hereby we have this technique called billboarding. So this technique is good to, as mentioned before, to simplify the game, the creation of a game, so I don't have to create a tree. And they also are less catchy in the game, which means they don't take so much attention of the users. So why spend so much time creating them? So let me go ahead and run the program and show how it works. So here's the program, and as you can see, this is the normal cube object, and this is the cube with the billboarding shader in it. So for example, if I move this object up and down, left and right, and zoom in and out, you can see that it doesn't change, it always facing the camera. But if I do with this big cube, you can see, then I can see the side of it, I can see the top of it, I can see the rear, etc. Alright, so basically this is the technique, and that's how it works. I use the same texture to prove it. So let me go ahead and run the code. I'll view the code and then explain explain the whys behind the code. Here's the code that I've used, and you can see here we have the name for the shader that we started to use, and then we come down to the properties. Excuse me. All right. The property are basically shader properties. We define shader property as a specific property of the object. What property is what appears in the spectre in Unity, and then we would modify or add values to the objects and the properties. The property used in our case is a cube. Yeah, is a cube, which lets us create a normal texture for our object to be used as a billboard. Without this option, we wouldn't apply any texture to the object, so it would be a plan to the it would be a plan box without no texture in it, without a billboard sign or anything. Okay, here we declare the input and output, and before we go through that, we have a uniform. And what uniforms are, they are global variables that we define in order to use for our program during our runtime. After defining the input and output of our program, we basically, what we do is we go through the technical part of the program. So how does our program solve our problem? Basically what it does is the following. The idea, it's pretty basic. So what does it do is that it transforms the origin of the billboard objects space to match the screen space, so that they always are rotated so they face the camera or the viewport, as we saw before. In order to achieve this, we have the equation over here. So we add the x and y value of the object, coordinates of the object, to the transformed origin in the view coordinates, and then transform the result to the projection matrix, which is this one. Sorry, this one. And then we multiply both. So that's how it is. And then we have a vertex shader defined over here that I have skipped on purposely. So what does it do when actually when using a vertex shader? We take full control of the standard 3D transformations of the billboard object. Hereby we disable Unity to so we don't permit Unity to scale or rotate it. In our case, we turn this 3D cube that we had before into a plain 2D object that is always facing the camera. And this over here is the pixel, and the pixel shader is actually just used to create materials that mimic the reality, that creates the object, that defines the object. For example, if you have a ball, you could make it a football by using a pixel shader, or a basketball, or whatever that suits best. In our case, we just use a sphere shader that shows the difference. So we have in our program multipasses, and what they do is actually as viewed over here, this one. So it caused the program to run to render the object just once. So we actually block it to be rendered only once. If we want to have multiple passes, then we should also be having multiple cameras and lights, depths, etc. But in our case, we only have one viewport or one camera, so we don't need others. So that's it, and thank you for listening. My name is Haidar Mahmoud, and this is the end of my video.